Okay, welcome to page 3. We're starting on page 3 now, and we've started with this: find the perimeter of the triangle round to the nearest tenth. Okay, so if I want to find the perimeter, that means I'm going to have to find all three sides. So if we want to call this H for hypotenuse and this B for base, it doesn't really matter, it's fine. I'm going to look and I'm going to say, look, this 24 is opposite. This is obviously hypotenuse, and this is going to leave this as adjacent. So now I need to use DOA, my trig here. So I want opposite and hypotenuse. That's going to be sine. So I'm going to start with sine. Sine theta equals opposite over hypotenuse. That's going to be 24 over h. So the sine of theta is 37 in this case. Sine of 37 degrees equals, opposite is 24, hypotenuse is h, we don't know it, and we're going to need to cross multiply and solve. Okay, cross multiplying, I'm going to multiply both sides by the h. Okay, and that's going to leave me h sine 37 equals 29. I'm sorry, that's 24. Okay, and then I want to get rid of that sine 37. Well, this is h times sine 37, so I need to divide to get rid of it. Sine 37, divide by sine 37. Okay, h equals 24 over sine 37. And I'm going to plug that once again into my calc, and I'm going to do it this way this time. 24, I'm going to use the little fraction button, and sine 37. Don't forget to close that parentheses. They don't like it if you don't. And 39 point, it says round to the nearest tenth, so the 7 is going to make it go up, so this is 39.9. And that was in inches. So I should have had 24 inches all along anyways. 24 inches, and that would have been 39.9 inches. Okay. Now, I need to be careful here, because if I round right now, I may be adding to the problem. So I'm going to go ahead and put 39.9 inches, but that is, I got to circle it. That's a rounding error. And if I add that together, I may be compiling my rounding errors. So let's do B here. I can use TOA because this is opposite and adjacent. So tangent of 37 equals opposite, which is 24, over adjacent, which is B. And I think as we've learned, we can just start switching these here. And so that's going to be, because this is going to be like this is a property of cross multiplication here. So B equals 24 divided by tan 37. Okay, so now if we want, we can find what the approximate that is. So 24 divided by, oh no, I don't want that. I want to go down. Divided by tan 37, close, equals approximately 31.8. Okay, but I don't really want to do that just yet. I want to make sure that I got the perimeter of all, which is 24 plus, I'm going to use the exact value here, 24 over sine 37 plus 24 over tan 37. And I'm going to just plug that into my calculator just like that, okay? So let's start with that. And I'm going to go up here and I'm going to say delete or clear. So I'm going to do 24 plus 24 over sine 37, close, and I pushed over here to get over, and then I'm at plus again, and then I'm going to do it again, 24 over tan 37, close, and now if I hit enter, it's going to give it to me in something that's been taken care of all, and it's not rounding until the very end. So 95.7 inches. Okay, good. Moving on to number 16. In the diagram below, what is the measure of angle M rounded to the nearest tenth? Okay, so this becomes our theta, angle M. And we got to look at it and say, well, you know what? How in the world did they expect me to take two side lengths and find an angle? That comes back to trig. So I'm going to look at this and say this is opposite, this is adjacent. Now I'm not really worried about hypotenuse right now. So what takes care of opposite and adjacent? Well, that's TOA, right? Tangent of theta equals opposite over adjacent. So I'm going to set this up. Tan theta equals opposite over adjacent. And so tan of theta, because I don't even know, I'm going to call it angle M or theta, it doesn't really matter, equals 3 over 4. Okay, so really I'm trying to solve for theta. I want to get, it's the only variable in here. Tan's not a variable, it's an operation, it's an algorithm. 3 and 4, they're numbers, so theta is the only thing I need to get by itself. So how do I get rid of tan? And this brings us into what we talked about the other day, which is untan. You remember I was untying the rope, right? Tan theta equals, I'm going to untan both sides. So that's called tan inverse or arctan. Tan inverse or arctan, or sometimes tan negative 1. And tan inverse of tan, since they are inverse operations, they actually undo each other and they leave the argument of the tan. This is called the argument, whatever's inside the parentheses. So right now the theta is the argument of this tan. And so they undo each other and leave the theta. And that leaves tan inverse of 3/4. Now, where is that? How do I do that? Well, it's once again on our calculator. Tan inverse is another algorithm that helps us find these angles. And if you'll look, it's right above tan, but it's got a shift key. So shift tan gives me tan inverse. And then I need to put 3 divided by 4 inside there and hit enter. If you wanted to put the fraction bar, it's fine. And that gives me 36.87. It says round to the nearest tenth. So I'm going to get 36.9. degrees, okay, because we are talking about an angle. Okay, so moving down to number 17. That is the reverse trig, inverse trig, or arctangent. Okay, find the area. Good. So for area, once again, I'm going to need base times height divided by 2. That's the area of a triangle. So I've got the base. It looks like what I need is this height. All right, so if I'm, just bug me. Okay, 30 and 12, I think I can use trig to find the height here. So this is going to be, oh, that's not opposite, silly Conaway. That's not hypotenuse either. Man, I am just really messing this up. So this is opposite, pointing there. This is hypotenuse, pointing here. And so opposite and hypotenuse, that is going to be sine. Sine theta equals opposite over hypotenuse. So sine of 30 degrees equals h over 12. Multiply both sides by 12. And I get h equals 12 sine 30 degrees, which h equals 6. And that looks like it's in centimeters, because this was centimeters, centimeters, centimeters. So 6 centimeters. Okay, and now, but I'm not really done. I've got to find the area. So I'm going to come up here and I'm going to use this. And I'm going to say area is equal to base times height divided by 2. So area is equal to base is 24 centimeters. Height is 6 centimeters. And that's going to be divided by 2. So I can do however I like here. And I'm just going to go ahead and reduce these two and leave me a 3. So area equals 3 times 20 is 60. 3 times 4 is 12. So 60 plus 12 is 72. And centimeters times centimeters is centimeters squared. And there we go. Okay. All right. What is the approximate measure of acute angle A when tan of A equals 0.698? So let's just write that down. Tan of A equals 0.698. Now, once again, we're in a situation, what is the unknown value here? What is the thing we don't know? The thing we don't know is what A is. Tangent's not a variable, it's an algorithm. These are all numbers, so I need to get rid of tangent. And that once again comes back to inverse tan. Okay, so inverse tan and tangent, they're like two knots that untie each other. Okay, and that leaves my argument A, angle A. Okay, great. And so now I'm going to plug this into my calculator, and I'm going to find inverse tan. I've still got the same one from last time, right? So inverse tan, shift tan, and I'm going to type in 0.698, 0.698, close, and hit equals. Remember, make sure, if you guys just now jumped in, make sure that you're in degree mode. That's signified by a little D in my case. If you were in radians, I think there'd be an R up there. If you're on a TI-83, you can find that under, or an 84, you can find that under the mode button on those calculators. But you want to be in degrees, not radians, for this work. 34.9 degrees. Okay, so number 4. In the diagram below, find the measure of angle Z, round to the nearest tenth. So, looking at angle Z, if I'm going to make that my theta, opposite is across, right? And I don't really care about that one in this case because there's nothing there that I can work with. But I do know this is hypotenuse, and that leaves 15 to be adjacent. So, it looks like I'm setting up cosine here because ca is adjacent in hypotenuse. So, if I get cosine of theta equals adjacent over hypotenuse, then I'm going to go ahead and put z in this time for theta. So I'm going to put cosine z equals adjacent is 15, hypotenuse is 17. The question is, how do I get rid of the cosine, right? Z is the only unknown, so once again, we're going to utilize arc cosine. I'm going to keep using different words just to throw you off. No, it's because there's different people that talk about it different ways. I want to make sure that you guys understand it. So arc cosine, inverse cosine, uncosine, right? They undo each other, and you get z equals cosine inverse or arc cosine of 15 over 17. People would probably be unhappy with me for using cosine instead of cosine. I don't know. It's all up to tomato. Let's see. Z is cosine inverse of 15 over 17. So delete. At this point, you're probably just like, shut up, Mr. Conaway. I can't follow anyways. And I'm going to get 28. Looks like 28.1 if I round to the 10th. Okay, 28.1 if I round to the 10th. Put that back up there in case you guys want to see that again. 28.1. Okay, moving on to number 5. Number 5 says we're going to once again we're going to go look at number 4, but we want to find the measure of xy this time. So basically, we're finding the third piece. And now there's lots of ways you can do this, but I would say the easiest way, if I just call this B, is Pythagorean's theorem. I like Pythagorean's theorem. It's pretty quick, simple, and just rudimentary. So I'm going to use a squared plus b squared equals c squared, where a and b are b and 15 here, and 17. So I'll call 15a. So this is 15 squared plus b squared equals 17 squared. Okay. And I'm going to use this here. 15 squared equals 225. 17 squared, 289. Subtracting the 225, and I'm going to get b squared equals, that looks like a difference of 64. Is that right? 289 minus 225 equals 64. Wow, look at that. That's nice. 64. Why is that nice? Because when I take a square root of it, I'm going to get a whole number. Remember, we normally need to think about the positive and negative root of a square root, but not in the case of length in geometry. Next year in calculus or in algebra you will need to. So b equals the positive 8, because that's the root of 64. So this was actually what we called a Pythagorean triple. It's the 8, 15, 17 Pythagorean triple, okay? Because a triple is any right triangle that has 3 integer numbers, 3 positive integer numbers, so whole numbers. Although I disagree, I believe that decimals should be okay too, like 4 and 7.5 and 9.5, or 8. Yeah. So anyway, let's not get lost here. So number 21, the last one for this page. Angle 28. This is the opposite from it. And they want me to find what are the measures of AB. So I'm going to call this one hypotenuse, and CB, which is adjacent, around to the nearest tenth. Okay, so it looks like I could use, I'm going to have to use both here. I've got opposite and hypotenuse, I might as well use sine. So sine theta equals opposite over hypotenuse. So the sine of 28 equals 22 over the hypotenuse, which we don't know. We're just going to call that side AB. So multiply both sides by AB. Divide by sine 28, and I'm going to get AB equals 22 over sine 28 degrees. AB is approximately 22 divided by sine 28, close, approximately 46.9. I think it says round to the 10th, right? So 46.9, and that is no units, so we'll just call it units. Okay, setting up adjacent and opposite here. So tan theta equals opposite over adjacent, and we're going to get tan of 28 equals opposite, which is 22, adjacent, which is called BC. So multiply both sides by BC. In the end, we know this little trick. These two are going to switch, and we're going to end up getting BC equals 22 over tan 28. BC is 22 divided by tan 28, 41.4. All right, that's 45 minutes. That's 21 questions. These were pretty good. That's going to be more questions right there than were on your test. Now, I'm going to go ahead and finish this slide, and we're going to move on to the next page.